Hello, my name is Cody Ebberson. I am the CTO at Medplum, and today we're going to talk about the Medplum Agent and give a quick demo of the Medplum Agent. Overall, we're going to talk about the HL7 problem, about getting HL7 data off of local devices and into the cloud. We'll talk about the Medplum solution to the HL7 problem, and then I'll prepare everything necessary to install the agent. We'll install the agent. We'll run Sim Hospital, so demonstrate streaming data into the cloud. And then we'll look at that data in S3, and then we'll also look at that data in AWS Athena. First, let's talk about the problem. So many healthcare organizations need to interface and connect with on-premise endpoints. An endpoint here could be an on-premise EHR like Epic or Cerner or Allscripts. It could be a device such as lab instruments. It could be other supplementary software like a radiology information system, a RIS or a PACS. You often need to connect to those protocols, but they're often unencrypted legacy protocols such as HL7 v2 or HL7 MLLP, which often poses this big problem. How do you connect to those endpoints? And how do you do it securely? And how do you get that data up into the cloud? There's lots of unfortunate solutions out there, such as doing big, heavyweight site-to-site VPNs and connecting your Amazon VPC to the actual healthcare site. That's a lot. It's a big setup cost. It's a big maintenance cost. It's very fragile. It's not pleasant. So we have a better solution, which is the Medplum Agent. And our objectives with the Medplum Agent is we want customers to be able to very easily and securely communicate with these on-premise devices. We want it to be very simple and maintainable. We want to have this set it and forget it mentality. We want it to be capable of streaming many events. So some of the targets here, we have 100,000 messages per day from a single source. So the kind of upper bound here would be a hospital system EHR with an ADT feed that's streaming all patient events continuously. And then for a given Medplum cluster, we're targeting 10 million messages per day. So if you have a multi-site and multi-point deployment across maybe a hospital system, to be able to ingest 10 million messages per day, which comes out to about 100 to 200 messages per second. So the key features of the Medplum Agent, we want it to be really, really simple, a single file binary. We want it auto-updating. It's going to send and receive these HL7 messages and push it to the cloud. We want those to interface nicely with Medplum bots, which we'll talk about in a little bit. And we also want that data to land in S3 and be indexable by AWS Athena so that you can browse, navigate, run analytics, run diagnostics, run debugging, whatever you need to do, and as easy as possible. Here's a visual that maybe describes some of this a little better. The big picture, we have our site network here, which would refer to a hospital or a lab or a medical imaging center. And you have one or more of these various on-premise systems, an EHR, a RIS, a PACS, modality, et cetera, connecting to a Medplum agent over one of these legacy local area only network protocols, typically unencrypted, therefore it cannot go over the cloud. For HIPAA purposes, everything has to be encrypted in transit and at rest. So this data is going securely to the Medplum agent. The agent turns around and connects to the cloud securely using HTTPS and secure WebSockets. This is the Medplum cloud. Now this could be the Medplum hosted environment, or it could be your own hosted environment. The agent works in either case. Those messages then can optionally get processed by bots, which is the Medplum secure wrapper for AWS Lambdas. The data can go into S3, it can go into CloudWatch logs, it can go into an RDS database. Lots of different options here for how and where that data goes, how it gets processed, how it gets sliced and diced. So here I am on the Medplum staging environment. This is a test environment that we often use, no PHI. I'm going to create a new, fresh Medplum project. Medplum project is a secure unit of isolation. So it's going to be a clean slate called the agent demo. And here I have no patients. I have just one practitioner representing myself as the only user in the system. So the first thing that I am going to do is actually create an endpoint. An endpoint is a FHIR resource type. A FHIR endpoint represents a technical endpoint that can be used for connecting to electronic services. This is perfect for our needs. In the Medplum user interface, I'll go to Endpoint and click New. For status, I will start it as active. For my connection type, I will be using HL7 MLLP. For the name, agent, let's call this test endpoint. For my payload type, I will be any, and the address, MLLP://. I'm going to use the all zero IP address, which typically refers to the bind to all network interfaces. And I'm going to use the traditional port of 56,000. And OK. Okay, so this now we have a FHIR endpoint that represents something that we can connect to. Now this doesn't actually create the network endpoint yet. We'll get to that in a second, but we have an endpoint representation. Okay, next up, we need to create a bot. For that, I'm going to go to Project, Bots. I don't have any bots. I'm going to do a create a new bot. The name of the bot is, let's call this the HL7 bot. Create. I'm going to go to my new bot. I'm going to go to the bot editor. So by default, the bot is pretty much empty and it doesn't do anything. What we want to do is receive HL7 messages and send an ACK back. So here I'm going to add the HL7 message type from Medplum core. So we know that this bot will be receiving an HL7 message and we want to return an HL7 message. And here we're going to do the most simple thing, which is return event input. You can use the built-in helper build ACK. And that's it. So let's save. And let's deploy. And let's change our test input type to HL7. Here we have a sample ADT message. Let's click execute. And ta-da, we are receiving an auto-generated ACK message back. Awesome. So at this point, we have a working HL7 bot. The next thing we need to do is create an agent definition. You can think of this as kind of like the structure of the agent that we will create. So we're going to do new. We're going to call this the demo agent. Status will be active. And we're going to create a single channel. The endpoint is that test endpoint that we created earlier. And our target is a reference to the bot, which is our HL7 bot. And awesome. So now let's take stock of what we have. We have our Medplum project. We have a endpoint defined. We have a bot defined. We have an agent defined. And with all of that, we're ready to install the agent. Now, there's usually a Windows machine somewhere on the local area network. Usually your local IT administrator at the facility, at the site, at the hospital, at the imaging center will have access to one of these Windows machines and they will be authorized to install this software. I'm going to emulate that by going ahead and installing the Medplum agent on my local desktop here. So here's the Medplum installer. Click next to continue. And here's where we need to go grab those bits of information that we had set up before. You can find a client ID and client secret here in the project admin clients. I'm going to use the default client. And we'll go ahead and find its client ID and client secret. Normally you would not share these, only your administrators will be able to see them. These will be deleted and deactivated by the time we publish this video. And then we also need that agent ID that we created before as well. Go to the agent page and copy this agent ID. These are the 4 bits of information you need: your base URL, your client ID, client secret, and an agent ID. And with that, we can go ahead and click install. You probably saw a quick flash of a terminal there. That was us installing and then starting it into the Windows service. This is important because we want to make sure that this agent automatically starts when the machine starts, and it survives a Windows reboot. So I'll go ahead and click close. And if you want to make sure that it's running, we can go over to Windows Services, refresh, and there we go. Medplum Agent securely connects local devices to the Medplum cloud, and it is running. So now with that, we can actually go ahead and try and send a test message. Next, what we're going to do is run a project called Sim Hospital. This is a project from someone at Google, which will generate realistic and configurable hospital patient data in the HL7 v2 format. Great, really cool project. Thank you to Tara, the author of this project. To run it, we can do everything from Docker. So I'm going to flip over to a command prompt, and here is the command I'm going to run. This is the published Sim Hospital, the latest version. My output will be MLLP. My destination is my local IP address, port 56,000, and pathways per hour. A pathway is the Sim Hospital term for a workflow or a flow of a patient coming in, getting an order, or getting a test done. And for that, I will use 720 messages per hour, which comes out to one pathway every 5 seconds. So we can go ahead and hit enter to kick this off. The Docker image was already downloaded and installed on my local machine, so it's pretty fast. And now the messages are coming through. On the other side, what we can do is tail the logs in follow mode of all of the different log files in that agent directory. And here now we're receiving diagnostic messages. We received a message. Oh, here's a new HL7 message from Sim Hospital. And there's it sent the message to the Medplum bot, which generated an ACK, and the ACK went all the way back to Sim Hospital. So there, the message is going from Sim Hospital to the agent, over WebSock, to the cloud, to the Medplum bot running in a Lambda, which generates an ACK, and the ACK goes all the way back the full round trip, all over secure encrypted protocols. Medplum bots can be configured to save all of the bot input as raw contents in S3. We can take a look at that here. So here's my Medplum staging storage for this project, organized by date. And here are a whole bunch of tiny little JSON files that represent the input that has been sent out. Not only is it the raw HL7 message, it also includes some key metadata values that we can use for indexing. So let's take a quick look. I'm going to go ahead and download. So we can see here's the bot ID, content type, the actual HL7 message itself, and some of the MSH, so message segment header properties, such as the sending application facility, receiving message type, and the HL7 version. So now we're looking at AWS Athena. Athena is a tool that allows you to query data that is stored in Amazon S3. Here we have a staging demo bot logs table. You can see here some of the columns that exist, the bot ID, the content type, and a bunch of those HL7 header properties that we were talking about before. I can now run a query such as HL7. Here, let's select message type and count. So we're going to do counts by message type from this year, which because we just installed this is just today. So I can click run. And we have a whole bunch of ORUs, ADTs, and OUL messages. These messages are what you would expect. ADT, admit, discharge, and transfer messages, and ORU, those are some observation results. This is great. This is a great tool because you can hit AWS S3 with tons of data, easily hitting that scale that we were talking about before, the 10 million messages per day. And Athena can be used to very efficiently query that data for analytics purposes or debugging purposes, diagnostic purposes, etc. With that, we've seen a full end-to-end demo of the data coming from the device to the agent up into the cloud, being processed by a bot in AWS Lambda, and also data being persisted in S3 and then queried by AWS Athena. If you have any questions, please feel free to reach out. The Medplum Agent is in early alpha. We're working closely with some of our preferred partners. If you would like to learn more or if you would like to try it out, by all means, please contact us and let us know. We'd love to work with you. Thank you.